Добрый день. Добрый день. Вы меня слышите?
Да, вас слышим. Здравствуйте.
Хорошо, сейчас я... Так, секундочку, сейчас я дозагружусь, и мы начнем. Так, это здесь, это здесь. Так.
А можно по домашней спросить?
Да, конечно.
Вот там гамма М во второй задаче.
Да.
Вот. Там сумма по решетке по какой-то или по какому множеству?
Гамма n стоит сумма по всем целым числам, кроме нуля.
Угу. Хорошо. А вот эти эпсилон М в этой задаче, они не имеют отношения к рядам Эйзенштейна, да?
Нет, это они и есть.
Но вы их
Это
называете...
тригонометрические функции по Эйзенштейну.
Да, но это не сами ряды, да?
Не, сейчас ряды Эйзенштейна будут через них выражаться. Это на самом
Ага.
деле котангенсы.
Угу. Просто
Там однократная решетка периодически. Да.
у эпсилонов у них индексы нечетные бывают, а у самих рядов только четные.
Да, да, именно так.
Угу.
Так, ну что, начнем? Начнем? Как? Или еще чуть подождем? Ну что? Так, давайте посмотрим, а сколько вас? Сейчас, секунду. Ага, вас 7, то есть вас... подождите. Тут у меня еще... Я двоих не принял. Так. Так, 6 участников. Вас 6, да? Ну что, ждем еще 5 минут. Давайте подождем.
А можно пока вопрос по заданию?
Да, конечно.
Там вот в первой задаче говорится показать, что значит, ряд функций сходятся абсолютно и равномерно.
Да.
Мне как-то кажется, что для того, чтобы показать там периодичность и четность, достаточно показать, что ряд сходится в каждой точке абсолютно.
Да, конечно.
Зачем равномерная сходимость тогда?
Равномерная сходимость сейчас.
Ну понятно, что для свойств функции это нужно.
Она нужна для дифференцируемости, для формулы для производной.
Да, понятно. Спасибо.
Угу. Так, ну что, давайте еще я... Сейчас быстренько... Подождите еще чуть-чуть, и я приду. Okay, so we shall start. Is everybody here? I think so. Okay. So I start from some reminding that we perform fractional linear, such fractional linear transformation as his misprint, of course, with first epsilon. Then we get first that epsilon 0 is 1, as epsilon 1 at 0 is tends to infinity. And second, that the derivative of this function e of x is proportional to itself. So its Taylor series is just Taylor series for exponential function. And it's not so hard to check that the Taylor expansion converges to itself. So now I can invert this formula and express epsilon 1 as also convergent power series of exponents. And by differentiation, I get such decomposition for all these Eisenstein functions. So I want to mention that this decomposition depends in imaginary part of x, because so we have different development of this expression if x is imaginary part is real, is positive or negative. I hope it's clear, yeah? So it's standard troubles that, wait a minute. Where is it? So, oops, is it? Why? What happens? Oops, I don't. Why? Well, it doesn't look, doesn't see my. Oh, yeah. Nice. So, oops, why? Oops, sorry. 7, not so much. Okay. So the problem is, what is 1 divided by 1 minus a? So the first answer is that this is sum in a power I in power j from 1 to infinity. Do you agree? But this is true only if absolute value of a is smaller than 1. For a bigger than 1, we have another decomposition. So this is minus a inverse 1 minus a inverse. So if it's here from 0. So it is sum from j equal to 1 to infinity a in power minus j. Okay, so by this reason, the decomposition of epsilon, is different. Now, I move to the Eisenstein series, which is function of k defined by this series. This series is absolutely convergent. I have proved it. So I can sum it in such order in which I want. And I will sum in the following way. First, I sum over m equals 0, and then n runs from all integers except of 0. After this, I sum over positive m, and after this, I will sum over negative n. But first summation is in n, so just by definition, this sum over n can be calculated, and it is exactly this Eisenstein's epsilon. After this, I can expand it into the power series in Q and get this final answer. We can say more about, for example, what is gamma k. It's always possible to understand the expression of gamma k in terms of pi tilde and Bernoulli numbers and so on. But just for me, just for now, what is important for me is that this is convergent power series in Q. It's not so hard to check that it is convergent. So it's holomorphic function on the unit disk. Till 0, it's 0 also. Yes, the point Q equals 0 is nothing from the viewpoint of the upper half plane. Oh, sorry, Q is this, well, somewhere it is written. Where is it written? Yeah. No, sorry. Yeah, denote E of t by Q. So our example of the automorphic form is occasionally holomorphic function on the punctured disk, or on the non-punctured disk. So I can consider more restriction on my objects. So function f of 2, which is automorphic of the weight k, here it is written, and also we put condition that it has such a Q expansion on the punctured on the disk. I'm sorry for these formulas, but for me it's important as this is simultaneously the notation. In the theory of modular form, Q is exponential of 2 pi I 2. It's some convention, and numbers n is coefficient of this series. I will use it after this all time. Oh, sorry, and A, B, C, D are coefficients of 2 by 2 matrix. Some form remark. So you see that you have two conditions on function f, and there the intersection. So the information is something very complementary. So what is not complementary, that f is function not of t but of q, of exponential of 2 pi I 2. Indeed, it's based on the existence of such a matrix, 1, 1, 0, 1. It shifts 2 by 1, and the automorphic factor, which is important for modular form, is just 1. So this means that function f of 2 is 1 periodic. So it's natural to expect that it depends in exponential of 2.
Простите.
Yeah?
Я, наверное, пропустил. Почему там π с волной было?
So pi square.
Нет, вот ниже. Там, где у нас q, это e в степени...
Here's written. Pi tilde is square root of 3 gamma 2, and gamma 2 is double z of 2, so it's usual pi. I don't want to check that this is true pi. For me, it's absolutely non-important.
Ну, хорошо.
So I get strange definition of pi. Pi is square root of 6 zeta of 2.
Хорошо, ну то есть нам не важно то, что это на самом деле обычная π.
No, as I don't know what is p, pi.
Но вы только что пользовались, кажется, там периодичностью при сдвиге тау на единицу.
Yes, I know that this function is periodic.
Да, окей, спасибо.
With respect to shift by pi tilde, to pi tilde. Yeah. I avoid some, well, I really don't want to study seriously trigonometric functions. Okay. But now, if I will think about f as function of q, then I get a great trouble as express automorphicity, automorphic behavior. So what is action of SL2Z? I take q, take its logarithm. After this, perform some fractional linear transformation with it. And after this, take again exponential. So it's a very complicated function. So action of SL2Z is easily described in terms of tau. It acts on tau. But in terms of tau, it's very hard to explain what means this condition that this function is. It's not natural to well, so it's really it's simpler to explain in terms of q. So here some part is explained in tau description and another in q description. It is well, it happens, and this is maybe the main hard technical problem in conformal field theory, that they also want have two conditions. One is global, that this is some good function globally, and second, that its behavior near some points, so they shall use different coordinates and so on. Okay, so we have a definition of modular form. This is a rather classical object, and so I want first explain something about it. First, I want to talk about some property of this strange factor, C2 plus D. It is subject of the following relation. So here is strange combination CA plus DC. This is coefficient of the matrix, which is product of small ABCD times big capital ABCD. So this corresponds to the fact that this some compatibility with the multiplication. So first of all, this is the proof is evident check. Is it clear? I hope, yes. So this calculation is more or less evident, right? Just expand brackets and all. So what I want to say here that what is origin of this definition? So I have, let me denote by M of 2, A2 plus B, C2 plus D, or C2 plus D. Yeah, so this action, this is Möbius action. Then I can write that F of M1, M2 of 2, first of all, this is equal to something which depends in M1, M2, and F of 2. But I can apply it step by step, so it will be equal to something which depends in M1 and F of M2 of 2. Okay, so this is product of 2, M1, M2, F of 2. And this is just a property of compatibility of these two equations, that this prefactor coincide. So it's nothing complicated here, but nevertheless, I shall use it, and I shall check it. And so, as you will see, I will use it. So now I pass. Okay, so this is a very big, very interesting theory, and I demonstrate you of modular forms some beautiful results, but I shall wait a few as in prerequisites. I say that I claim that knowledge of theory function of complex variable should be important only later. But and this theory is based on this theory, the theory of complex function of the function of complex variable is basic tool in study, and I will demonstrate it with fun how it works. So I shall somehow try to move in other directions, and so for this I mentioned something that this is theory for related with group SL2R, and so there are another familiar group, and so what happens in it in this case? So SL2R acts by fractional linear transformation on upper half plane. I have explained this, yes? That real matrices with determinant 1 maps upper half plane to upper half plane. For this you shall check imaginary part. Shall I repeat? Oh.
No. Say what are A, B, C, and D? Capital.
A, B, C, and D. Where? No, A, B, C, D is coefficients of the matrix 2 by 2 all times.
No, we have capital A, B, C, and D.
This is matrix elements of another matrix. Then, oops, here's maybe. Oh no, that's okay.
They are matrices or numbers.
And all letters are numbers.
Okay.
No, I don't want to write C1, C2, and so on. It's absolutely horrible. It became something absolutely horrible. Okay, so now, indeed, any point 2, which is x plus yi, is a result. So first of all, this formula is true, and this is more or less evident. Second, here, on the right-hand side of this equation is written application of unimodular real matrix to element I. So this means that upper half plane is one orbit. Do you agree? So from this reason, if, for example, I put here +0. Should I draw the matrix? Okay, no, so no. On the other hand, it's easy to check what is stabilizer of point I. This is matrices of such shape. AB minus BA, which is just special orthogonal 2x2 group. And it's useful for me to identify it with unit circle in complex plane. Yes, such Z acts in basis 1I by this matrix. So if we have one orbit, the orbit is equal to coset of group by stabilizer. Okay. So we have the following beautiful remark that if I substitute an automorphic factor C2 plus D for such a matrix point I, that I get exactly, oops, why is the inverse? No, it's just Z, sorry. Okay. Now I can correspond to function on upper half plane. So somehow it's pulled back to the SL2R. So f of matrix is value of my function on image of I under this matrix, but turned by this factor. This is just modular, just automorphic factor. We shall see why I want to do this. Now so from this property, this cocycle property, we get that this function is no more invariant with respect to the stabilizer of I, but it multiplied by the character z go to z in power k. This is a rather classical object in the representation theory, in which you take function on the so I have B group G, compact subgroup K, representation of the compact subgroup, and after this you take functions on group which take values in this representation, such that the right action of the group maps acts on it as this group acts on the representation. This is induced representation. Have you heard about this? I don't want to move in this direction. It's big, beautiful theory, but maybe, well, so I think that surprisingly it appears in this theory of automorphic and modular forms. Now, why I want to multiply by this factor? As again, from the cocycle condition, from this we see that this function is just invariant with respect to action of SL to Z. So this factor, which appears from F, cancel with factor which appears from this power. So we are in a situation that we have some representation of group GL2R and modular and automorphic forms are such elements of this representation which are invariant with respect to the action of discrete group SL2Z. Okay? So
excuse me, here we had a function f, which was a function on upper half plane, as far as I understand.
Yes.
And then we construct a function f with this галочка.
Check.
Yeah, okay, f check, which
is
takes
function on SL2R.
Okay, that's great. And okay, that is defined in this strange way.
So its value on this matrix is first values of function f on the image of I on the action of this matrix turned by this factor.
Okay.
So this factor makes now f check SL2Z invariant. F is not invariant. F would multiply it by some factor, right?
You mean that f was initially the function, the automorphic function with k?
No, I want after this applied to it. Now so I just put such definition. See that this is not so bad from the viewpoint of representation theory.
And speaking about the representation theory, you've mentioned that we have this construction of induced representation, but as far as I know,
yes.
it works for arbitrary subgroup of our group, so it must not be compact.
For induced, it's better to be. Okay, so what? It will for finite group, but no, generically we can get some troubles if group is not compact.
Okay, thank you. Okay.
I'm sorry, but how is f checked not just taking any matrix to f of I?
Sorry?
Well, is f does it still have the property of the f from the previous slide?
Which one?
Can you roll it up a bit?
Yes.
Yeah, this one, the property A, does it have it? Or...
No, I can use this construction for any f. But if f is automorphic, then this f check will be invariant with respect to SL2Z. This is some preparation. Okay, so what is my dream? I want to realize automorphic functions in terms of group theory. Automorphic function f automorphic is not invariant with respect to something interesting. It is covariant. It multiplies. It would the action of group is equivalent to multiplication by some factor, right? You see?
Okay, and here you stay. Is it true that you state that only automorphic function of weight k are invariant on the action of SL2Z?
Sorry?
Ну, правда, что тогда только тогда? То есть у нас...
Yes, and this is nothing more than this this condition that this cocyclic condition. So again, let me return to here. so what I want to act on on argument of F by some another matrix, A capital, B capital, C capital, D capital, or conversely, yeah. So then what I get, I get two factors. One is automorphic factor which goes from F, as F is automorphic. And second, and that's all. But now from this formula, I get cancellation and get this automorphic factor of this first of this prefactor, but for new matrix, which is composition of these two matrices.
Okay, so if we write it down, it is clear, yes, from precise computations.
Just write and check. Yeah.
Okay.
It's nothing complicated. He has no non-trivial formulas except of estimate for convergence. All others algebra, and algebra is almost all empty signs. If you know formula, you can check it immediately. Okay.
Sorry, but if F is automorphic, isn't F checked just a constant?
No, F is covariant with respect to the discrete subgroup.
Oh, yeah, okay, thanks.
Okay. Now, so the next, my aim is to explain that in this approach, I don't lost my example. So what can I understand what is Eisenstein series from this viewpoint?
Is it true that we need to know the values of F check only on a fundamental parallelogram?
What is fundamental parallelogram? All this is very curvy. This is group SL2R, in which you place SL2Z. It's two very curvy objects.
This is not a function on upper half plane.
F check?
Yes.
No.
Okay.
No. I will talk about fundamental domains for some actions, but this is not good time. It's more or less understandable what is an analog of fundamental parallelogram for upper half plane. But for SL2R, I have no idea.
The last question.
Yes.
What is the action of SO2R on SL2R?
Multiplication by left. From right, sorry.
Matrix SL2R is multiplied by
matrix from SO from the right.
Okay.
And so it induces action at its action on the group, and so it's a representation on the function on the group.
Okay.
Okay. Okay. So we are again in the situation that we have representation, namely induced from character representation of SL2R, and we have action on it of SL2Z. You want to construct invariant elements. So the first idea is just average over of all group. But this is bad by the following stupid reason, that the matrix of the group of unipotent matrices You see what it is, yeah? 1B01. So unipotent means that it is upper triangular and has unit on the diagonal. Here's a funny story why I call it N. Do you know? Because in representation theory, this group is known as nilpotent group. Why? But element is nilpotent if it has zeros on the diagonal. So this comes from the fact that the algebra of this group is nilpotent, so a group also is nilpotent. Strange definition. Yeah. So this automorphic factor is trivial for such elements. As you see, C is equal 0, D is equal 1. So C2 plus D is equal 1. So hence, this automorphic factor does not depend on the left conjugation, not conjugation, but left, oops, I forget what, left class, yeah, okay, yeah, so how как будет смежный класс? Никто не помнит?
Я не помню.
А?
Без малейшего понятия.
Sorry. So this essentially this is function not on SL2 but on such a coset. So we can average the powers of this C2 plus D, but not over SL2Z, but over SL2Z over such coset, where gamma infinity is integer matrices of such a shape.
And why it is called gamma infinity?
As its stabilizer of the point infinity. Matrices of such shape, 1B01, is stabilizer of point infinity on the projective line.
But why do they have integer coefficients?
Now this is, okay, so for SL2Z, they're called gamma infinity, a stabilizer of SL2Z, so I want to mention that N is not stabilizer of infinity. Stabilizer is much bigger. Stabilizer is just all functions, all upper triangular function, or upper triangular matrices. But if you have upper triangular integer matrices with determinant 1, so they are forced to be 1, 1, or minus 1, minus 1 on the diagonal. So the stabilizer of infinity is Borel subgroup, which is known as B, and not N. Okay?
Okay, thank you.
And
So,
question. And here you mean the quotient of SL to Z by gamma infinity, yes?
yeah.
You write it in very strange way.
Why?
Gamma infinity. I
want to
understand.
take left classes, not right. So what's strange for you? Notation?
Да, но как бы гамма бесконечность слэш SL2 обычно как бы фактор группа, там сначала SL2, потом слэш.
No, it isn't group. It's set. And if you take quotient by non-normal subgroup, then you should keep accuracy from which side you act.
Mm-hmm.
And coset normally means класс эквивалентности.
Yes.
So that's a bit confusing.
Множество классов эквивалентности. Множество смежных классов.
Ну, кассет, он вроде один, ну, типа один из классов, он кассет.
Нет, косет — это множество смежных классов. Множество кассет, да, множество, да. Нехорошо говорю. Yes, it's set of cassettes. Sorry. No, coset is
the quotient consists of cosets.
Sure, maybe. Sorry. Okay. Yeah. So now we have description of such object, and so surprisingly we shall directly go to the number theory immediately from the group theory to number theory. The claim is that this set can be identified with a set of pairs of coprime numbers, CD. Okay, why? Okay, the reason is very simple. Of course, if I put CD, this means that I take the last row of matrix. So what is gamma infinity orbit? So I'll act from left by multiplication by a matrix of such shape. This change only A and B and shifted in such way. Elementary calculation. So really pair CD is function on orbit, is constant on orbit. Okay, now the next claim is that this map is surjective. So for, as matrix has determined 1, CD are coprime. In opposite case, the common divisor should divide determinant, right? Okay. So now the claim is that if C and D are coprime, then I can restore them to the unipotent matrix. Indeed. So you have, according to the Euclid algorithm, the greatest common divisor of C and D has linear representation of the shape XC plus YD. I hope that it's all known to all of you. Is it?
Yes, definitely.
So the matrix Y minus X CD is unipotent. It's exactly what is written here. And its image is C and D. So we get surjectivity. Now inductivity, it's again the problem how to, so first this, if C and D are coprime, that this equation is solvable. And now how much solution do you have? Okay, so if you have two solutions, then the difference is equal to, such a difference equal to 0. Then C are coprime. So A prime minus I is divisible by C. And after this all, what you want, you get that A prime, yeah. So it's again rather elementary, but number theory. So you see this strange mix of different branches of mathematics. So maybe I want to say, maybe it's reasonable to say more about number theory. So this is formula for Eisenstein series, right? a priori non-number theory. Now, what is coefficient of Q in this, in Q some power? So it's sum over all divisors of this exponent in power k minus 1. Absolutely number theoretic function. So from strange. So, for example, Donzagier has an opinion that number theory is just a part of theory of model functions, model forms. Okay. So this set of cosets is just set of pairs CD, and this averaging will be averaging of the expression C2 plus D in power minus K over CD coprime. So it looks very like Eisenstein series, but in Eisenstein series you sum not C2 plus D, but M2 plus N. And this is absolutely different thing. Yes, CD is coprime and M and N no, but we have unique decomposition of any pair of Mn into product of some positive integer and coprime pair. F is just greater common divisor. So the usual Eisenstein series, as we have defined it, we can split, factorize any term in product of 2. F is n in integer, and C and D are coprime. And this is one-to-one correspondence. So this is just, this sum splits into product, factorizing the product of inverse powers of natural numbers, and this sum which comes from the averaging of through group theoretic approach. So here is trouble. So psychological trouble. If somebody talk you Eisenstein series, you shall check which sum have he in mind. So sum over M and N or sum over C and D. They're very close, but explicitly this is absolutely, so you have some non-trivial factor. So for example, for E4, its factor, this is pi, this zeta of zeta of 4 is pi in fourth over 90, yeah?
Yeah, over 90, I believe.
I also do. Okay, so, but now, so what is bonus, what is profit, that I realize Eisenstein series purely from the group theoretical speculation. So I don't think about that we have some letters and so on. I use only group GL2R, discrete subgroup on it, compact subgroup of it, some special function on it. But nevertheless, it's purely group theoretical approach. So from this we can hope that we can do something like this for another groups. So I think that today will be all what I want to say. How much is time? Oh, only 1 hour. Okay, so let me discuss with you some administrative problems. Is it true that all who want to pass through exam understand that that the homework is not from exam, yeah. So if you want to pass through exam, you must prepare homeworks. So homework was on the site. Does everybody understand this or not? Do you have some troubles with homework? Is it clear that I shall get it before next lecture?
Yeah, but you on the last lecture you said that we have to discuss it orally after we send the solutions. So should we also do that before the deadline?
No. I only want to have written just in order for understand what is your situation. So is everybody who want to pass through exam, are they here or not? Okay, it's a stupid question. If they answer, they will keep silence. Okay, so okay, how much person here want to pass through exam?
I want.
I do.
2.
I want.
3.
Yes.
4.
And that's all.
That's all. 4. And all are Russians. Or not?
Да, здесь был один человек с китайской фамилией, но он куда-то делся.
Ну хорошо. Так. Okay. So we have. I have 2 days for talk. Thursday, so Wednesday and Thursday. After next lecture. So, but if there are only, is it suitable? Maybe some days are bad for somebody.
For me, it would be more convenient to talk on Wednesday in the first half of the day.
Oh, maybe it's also possible. I can open this, and so yeah. Okay, so please. So you. Well, I think this is reasonable in 1 week when I get all solutions, discuss when it's more suitable for you, right?
Okay, and I forgot, do we, okay, so we, I want to, сейчас, секунду, мне нужно послать вам решение по почте, правильно? У нас нет там какого-нибудь телеграм-канала или, не знаю.
Не, зачем вам телеграм-канал?
Ну, нет, просто на всех курсах есть. Ну, хорошо.
Не, вы знаете, я очень боюсь. Дальше выяснится, что он лег. Знаете, положить Gmail — это все-таки целое дело. Я доверяю. Okay, so till next lecture, I hope that I prepare a reasonable version of the presentation in a few days and put it on the site. Okay. See you. Bye-bye.
Bye-bye.
Goodbye.